Hello everyone, welcome back. In this final video in our game tutorial series, what we're going to be doing is basically putting the finishing touches to our project. We have something that kind of looks like a game, right? We just covered game states in the previous video, but right now it's really boring. We just have the one player and the one zombie. So obviously we need to spice this up a little bit. We're also going to do some cosmetic improvements, things like changing the fonts for the title and so forth. And then we're all, letting the player choose a different character skin just to make it a little bit more interesting. And then we'll also talk about some of the finer details of, kind of the game logic that's happening under the scenes, how to refine this a little bit when it comes to where the enemies spawn and also their behavior. That's make it a little bit less predictable, a little bit more zombie-like. So lots of odds and ends in this video. So let's just dive right into it. So let's start with some of the cosmetic updates, and then we're going to turn our attention to the zombies and kind of get them to increase over time and tweak their behaviors. Okay. So an easy place to start would be the fonts. Okay, so if we hit our starting screen here, this is not super beautiful. We're going to add a font for this. We're going to stick to Arial for our instructions, but the zombie apocalypse, I'm going to use this font here that I uploaded called greenfuzz.ttf. Okay. So as we saw in week 7, if we want to create different fonts, we're going to create variables, and we're going to use load font to bring our TTF font into our program. Now our title font, right, is going to be an external font that we bring in. And then the other font, I guess let's call it default font, we're going to just use a string to define it because we're going to use Arial, whatever. Every computer has it built in, so we're not going to bring a TTF file for that. So we can do a mix of them, okay, and we'll be able to use either of these interchangeably with the text font command to kind of switch between them. Okay? So in preload, we're going to set title font to loading this file that I have over here, greenfuzz.ttf. So we're going to load this font in preload. And then when it comes time to do our intro, we're going to set title font, right? And we're going to set the default font. Okay, so we're going to have two different fonts here that we can switch between. Let's run this. Okay, and that looks like that. Okay. So that's, we could do this. If I wanted an easy way, by the way, to have this over kind of 2 lines, I think in the example I showed you is 2 lines. You can add a new line character using \n inside any string. Okay, and that would basically, that's going to add a new line and then have your string unfold on multiple lines. If you wanted to set it up like that, you could do this. Let's, while we're at it, also change the fonts for the game over screen. So same idea. We're going to set a title font, and then we're going to set a default font. Cool. So small improvement, but it's starting to look a little bit better already. The next thing we can add to this is to make it a little bit more interesting is we're going to add the concept of a score. Okay, and I think this is what's going to make it a little bit more of a game, because without a score, we have no idea how well we're doing. Are we beating our score? There's no real incentive to keep trying to get better at this game if we don't have any kind of feedback from the game. So adding a score is an easy way that we can do this. So what is the score in this game? Well, it simply can be just a number that goes up, right? It can be very arbitrary. And if we need to remember some kind of value, some kind of score, the implication is always we're going to need some variable to represent that concept. So whenever we add detail to our program, that almost always translates to more variables. That's just how it works. So if we have a score variable, now all of a sudden we have something we can increase over time to keep track of the player's score. We could draw that score, right? Let's say we're going to draw it in the top left corner in this game. Now I know I'm going to have to draw the score in the intro screen and also in the game over screen. Sorry, not in the intro. no score in the intro, in the run game, and in the game over screen. Okay, so I need to do it in 2 places. So in order to avoid repeating myself, I'm going to write another tiny little command called draw score. And the idea here is that, even though I'm just going to have a few lines of code here to draw the score, maybe we'll set the default font, right? Maybe we'll set a white fill, and then we'll draw score, which maybe we'll put top left corner somewhere here, and we'll set a text size 20, maybe 40. Let's see what that looks like. So now I have a command that I can use. So whenever I want to draw the score, I can draw it here, and I can draw it here. Okay. So whenever you find yourself doing something in more than one place, right? This is always a good candidate for yet another function. Right? So now I have my score up here, right? And if I'm game over, I have my score up there. Obviously, the score is always 0 right now. So what if we wanted the score to go up the longer we play? Well, we have this run game state, right? So as this repeats, in addition to drawing the score, we could simply say every frame that our player has survived, let's give him 1 point. We're just going to increase the score by 1. So now we have this counter that goes up, right? And that just becomes my score. If I get caught by a zombie, right, the score freezes. Why does it freeze? Because in game over, we no longer increase the score. We just display it. Right? And then finally, if I want to try again, it would make sense if this score counter went back down to 0. Currently, if I try again, it just keeps going up from where my previous score was. So in order to fix that, we then have to find where is it that we go from the game over state to the run game state. And oh, actually, we should also change the text alignment here. Text align left, right? And then here we should go back to text align center. Actually, let's just put left and get rid of text align from setup before we move on. And we're going to use center text for this and for the intro as well. Okay. Small detail. As the score gets higher, the alignment would be a little bit wacky. So now it's over there. Okay. Let's adjust. Maybe draw it at 0. Maybe 10. Okay. You can kind of do some trial and error to find positions like so. Okay, that looks better. And now it's going to increase correctly. Okay. So where do we reset the score? Back to 0? Well, if game state is game over, this is where we jump back into a new game, right? So this is a good time to also reset the score, right? So now we can start, and the score increases, the zombie catches me, try again, score goes back to 0. So building our game now becomes a matter of figuring out when we want things to happen and under what conditions. And we have already a framework for all those things to happen within. All right. So we've added some cosmetic improvements. We've put some fonts in there, added a score. The last cosmetic improvement we're going to do before we turn our attention to the zombies, which is really the important part, is we're going to add the concept of player select. Okay. So we're going to load in an alternative animation sequence, right, called fPlayer. And then when we first create the player, we're going to be able to decide which image sequence we want to use. Okay. So step 1, let's bring in our other animation sequence. So let's create another array called, let's call it fPlayer frames. So we remember we have the male player and the female player. It's going to be an array, right? And in preload, we're going to use our load frames function to quickly go and load another array of frames. So in my game here, I have these fPlayer images. They go from 0 to 8, so I have 9 of them. So we're going to load these frames. See, building that load frames function is paying off, because now we can quickly just load another sequence, right? We could do this as many times as we need. This one also has 9 frames. So now I have 2 different arrays that I could choose from, right? So let's update our intro state, right? We're going to update our intro state to now draw mPlayer frame 0 and also draw fPlayer frame 0. Okay? So now they're going to be on top of each other. So let's move the mPlayer to the left a little bit, move over by 100, move over the fPlayer by 100 to the right. And now we should see, oh, sorry, I can't do that here. My bad. I meant to do this with the X coordinate. Sorry about that. Okay, so now we have our 2 players, right? And what we could do, if we look at the player class, right, this is what determines which animation sequence our player will be using. If I were to replace this with fPlayer frames, right, now I'd be using a different sequence, right? So we just need a little bit of code that's going to decide which one of these to use at the beginning of the game. Okay? There's a number of places where this could occur. We could do this when we create the player object. Okay? That seems like a good place to do it. And or we could do this when we go from, run intro to run game. Okay, that would be another place. And basically, we can make that decision based on the position of the mouse cursor. Now, for simplicity here, I'm not going to bother with making sure I actually click on the correct image. We're just going to say, if I click on the left, I'm going to be mPlayer, and if I click on the right, I'm going to be fPlayer. Okay, so that's kind of a lazy way out of this, but we'll simply say if mouse X is less than half the width, right, at the time of creating the player object, we're going to do that. And then otherwise, we're going to use fPlayer. Okay, so kind of like a lazy way out, but it'll do the job for us. And instinctively, your players are probably just going to click on them anyway, so they'll never know that you can click anywhere and still get a player. Okay? And we're also going to make sure that we create our player object. We're going to, oh, actually, we can't do that. We need the player object in the beginning because oh no, we don't. We're going to create the player object, not in setup. We're going to create the player object in here. So when we create mouse pressed, right? When we go from game state equals intro, when we jump into the game, we're also now going to create our player object. Okay, and in turn, that's going to run the constructor, and the constructor is going to decide which animation sequence to use based on the mouse cursor position. Let's try that out. So now we're drawing the player's images, but remember, all we're doing is we're drawing them based on the image arrays. So we haven't created a player object yet. That's going to happen as soon as we press the mouse. Okay? Perfect. And if I click on the right side, now I get this player instead. Amazing. Okay, so we have a score, we have some fancy fonts, and we can choose between player 1 or player 2. So now let's talk about the zombies, right? Let's make this game a little bit more interesting. Currently, I only have 1 zombie. Pretty boring. Let's make it so that I have multiple zombies. Okay? So this first step is going to be, let's turn this single zombie variable, let's turn that into an array. Instead of having 1 zombie, I would like to have an array of zombies. Okay. So as a starting point, we might do something where in setup, obviously this is not going to work anymore because we've turned that variable into an array. So in setup, we are going to say, just to kind of test with, right? Let's write a quick little for loop here. We're going to start with 5 zombies. Let's say zombies bracket I equals new zombie. Okay. So this is going to go and set up, repeat 5 times, and then create 5 zombies for us, put them into this zombies array. And then inside run game, right? Now we just have we don't have one zombie anymore, we have multiple. So this bit of code here, we need to repeat it over and over for each zombie we have in the game. So we're going to write a for loop, and we're going to use the shorthand syntax because we don't care about the index of the zombie at this point. We're going to say for every zombie inside the array zombies, right, we are going to repeat this section of code, right? So what we used to do for one zombie, we're not going to do it for all of them, right? So this is the syntax to do that. And that's going to say, tell that zombie to move, animate, and draw. And also, while we're at it, check for collision with the player. And if any one of them hits the player, we're going to immediately switch to the game over game state. And then finally, we're going to also update the game over function, right? Because now we don't have one zombie, we have a bunch. We're going to say for zombie of zombies, right? You're also going to draw all the zombies that we have so that we can have the freeze frame. Okay. So let's hit play. So now we start with 5 zombies, right? And this, it's very easy to implement because we've wrote everything as a class. So making more zombies is simple as just creating more copies, right? More instantiating more objects here. As long as we remember to, in run game, using a for loop to move, animate, and draw all of these objects, and then of course do collision with the player for all of them. Right? And if any one of them catches me, it's game over. Okay. Now, if I try again, obviously the zombies all stay the same, and they stay exactly where they are because we're still using the same 5 zombie objects. Now, one thing that could make this game a lot more interesting is instead of having a fixed number of zombies, what if we started with no zombies, right? And then over time, we start to bring in some additional zombies into the game so that it's going to get harder and harder over time. And, eventually we're going to lose for sure because the screen will be filled with zombies. But that's the deal with the zombie apocalypse. There's no winners. You can only survive as long as you can. So let's see how we would program something like that. So what that means is instead of creating 5 zombies in setup, we're just going to do nothing. Okay? We're just going to start with an empty array, right? There are no zombies, right? Everything's good. Now what we need to do is over time, as we run the game, we're going to introduce new enemies, right? Over time. So we cannot introduce a new zombie in every frame because that would be way too challenging, but let's see what that would look like. Okay, so we could say add zombies over time, right? We're going to say zombie equals new zombie, right? And then we could say zombies dot push zombie. So we saw in last week's tutorial that if we have an array, we can use its push command to dynamically add objects to the end of that array. So this would take the variable we created here and then add it to the list. Now this is going to get crazy real fast, right? Holy crap. Okay. This is a little bit too hard, right? We could also cut to the chase here. Instead of having a temporary variable, I could also just say push new zombie, right? That works as well. And just get rid of this. Okay. So I can write the same thing like that. So clearly 1 zombie every frame, it's a little bit much. Okay, so we want to slow down a little bit here. So how could we do this? Well, let's use the same strategy we used in our animation, right? So here we're animating the frame index whenever frame count is a multiple of 4. Okay? So we could use that same idea to introduce zombies once in a while, but not all the time. Okay? So for example, we could look at our score, right? We could look at our score variable and say whenever we reach a threshold of the score, maybe a multiple of 200, right? Whenever score is a multiple of 200, and the way we write this in code is we use modulo, right? So this is how we ask that question. It says divide score by 200, and if it's an even, if you get 0 left over, it means we have a multiple of 200. Then we add a zombie, right? So add zombies every 200 points, for example. That could be a way we could do this. And now we're going to start with none. And then as soon as we hit 200 here, a new zombie will appear. Right? And then at 400, we'll get 1. I just made up that number, 200. If we lower it, obviously zombies will come in faster and so forth. So you can do a little bit of play testing to figure out what feels right for your game. These are, details you can easily tweak. So over time now, this is adding more and more zombies to the game. Okay, so this is kind of a cool, cool mechanic. And if a zombie catches me, right, it's game over. Now, if we try again, it would be nice if we could have a clean slate for our next attempt instead of having to start with a billion zombies again. So we can easily do that right over here, just like we reset the score. Let's also reset the zombies. We'll say zombies equal a brand new empty array, right? So if we do this, this is basically going to wipe out everything that was there and replace it with a fresh empty array with nothing in it. Okay. So that's a great way to clear out these objects, right? Let's wait a couple seconds here. I'm going to have 1 or 2, right? Let's add a third one and then let's let it kill us. No. If I click to try again, it will not only change the game state, reset the score, it will also clear out the zombies, right? Now we go back to a fresh start. Awesome. Okay. All right. So already, I think our game is in a pretty good shape, but we could probably do a little bit better as well in a couple of respects. One is a little subtle, okay? But if you play this game enough, which I have a lot, you'll notice that eventually something really bad is going to happen where a zombie is just going to appear randomly on top of the player and just kill us. Okay? We could not care as the designers of this game and just say, whatever, tough luck, this happens. And but it's kind of cheap. Okay, so let's talk about how we would refine the zombie spawning code so that we don't accidentally just kill the player. We at least give him a chance to survive. And what that means is that before we create a new zombie, we should make sure that wherever we put that zombie is not right on top of the player. Okay, so let's be a little bit nice as the developers and make sure that scenario doesn't happen. We may not see it happen here, but it can definitely happen. Okay, so eventually if you play enough, this will happen to you and you'll be like, why did I die, right? I was avoiding all the zombies. It's not very nice. And the reason it can happen is because in the zombie class, we don't discriminate, right? We just randomly create zombies regardless of what's happening with the player, right? So how would we solve this problem, right? Basically, it's kind of a trial and error process. What we're going to do is we're going to say, okay, create the zombie with a random position and then check, is that killing the player, right? What does that mean? Well, if that zombie collides with the player, then yes, it will kill the player. So if that's the case, we're just going to try again, right? We're going to come up with a new position. And we're going to do that as long as it takes until we find a position that doesn't kill the player. So most likely, it's going to get it right on the second try, but it may not. Okay, so let's talk about what that means. So I'm going to move this down here a little bit. So we're going to do that. We're going to say create a random coordinate, right? And then we're going to check, does this kill the player? So how do we check? Well, we have a collision function. We can just use it. We're going to say if this dot x, this dot y, oh, actually, no, if this, right? So if this and player, no, sorry, let me backtrack. If collision between this and player, right? So remember, collision wants two objects as its parameters. It wants object A and object B, right? Whereas collision is up here, right? So those could be anything, right? So when we're in the constructor of our zombie here, this refers to the zombie object itself. So we can just pass the keyword this, and it's going to refer to the object we're currently building. So if collision between this dot player occurs, right? If that's true, then we're going to come up with a new random position. Okay? So this is already an improvement. It means that if for some reason the zombie spawns right on top of the player, right, and that would collide with the player, we're going to randomly create another position for the zombie. Okay? But what if we're really, really unlucky, right? What if it spawns on top of the player? We find that it would kill the player, so we come up with another coordinate, and that is random again, so it could also be on top of the player, right? It could happen twice in a row. It's not impossible, but it could happen. It's not likely, sorry, but it could definitely happen, right? So what we really want to do here is we want to find a safe space to drop our zombie that we know for sure is not going to kill the player. So this is a great job for the while loop. Okay. The while loop is nice because it will do something, it will repeat something for an uncertain number of times, right? And remember when we first introduced loops at the beginning of this tutorial, I said it's difficult to give a good example of a while loop that isn't based on counting. Well, this is one of those times when the while loop is going to basically repeat, right, until it finds a safe space for our player. So we're going to structure it like so. There's a couple of ways we can structure the while loop, but there is this one where we can say do something, right? We'll say do, so we'll say create a random position, right? Do this, so that's a bit of syntax, and then we'll say while, so keep doing this, right? As long as this condition here is true, right? So as long as we have a collision between the zombie and the player, so as long as this condition is true, this structure here is going to repeat, right? We use the do while construct because this allows us to start with the code and then put the condition at the end of the loop, which is convenient in this case. So this is an example, right? A simple algorithm, right? So this is a simple little algorithm here that will make sure the new zombie doesn't kill the player right away. Right? So what we do is we say create a random position, right? And if that happens to kill the player, try again, right? And it's going to do this as long as it takes until this is false, right? And technically there's a danger for an infinite loop, but in practice, right, it would be very, very unlikely to continuously get random coordinates that kill the player. Odds are, 2 or 3 in a row is probably the most we'll ever see, but this guarantees that this new zombie will appear somewhere that is not right on top of the player. Right? And in fact, in order for this to work, we need to make sure that we do this after we've defined a radius, because remember, this collision function relies on the radius. So we are going to move that down over here. Almost made a mistake here. So this is important because otherwise the radius was undefined, right? And it would just basically never find a correct collision. Okay, so when we create new zombies, it will check, does it kill the player, and it will keep trying until it finds a spot that is not going to kill the player, at least not right away. So that's a great little improvement. The final improvement we're going to make, and then we're going to call this particular version of the game complete, is we're going to work a little bit on the behavior of the zombies, make their motion a little bit more interesting. So instead of just always moving in a straight line, right, as they do right now, this is basically our bouncing ball code we programmed earlier in the semester. We're going to make these zombies a little bit more unpredictable, right? So the way we're going to do this is we're going to use probabilities. We're going to say once in a while, the zombie is going to randomly change its mind. Okay, who knows what goes inside of there? It's just going to pick a random direction, and that's going to that's going to force the player to stay on their toes a little bit more. Okay, so randomly our zombie might start going into a totally new random direction. Okay, so this is how the zombie gets its direction initially. So let's make its motion code a little bit more interesting. We're going to say once in a while, okay, go into a different direction. Now we could do something based on frame count, right? But that would be a little bit too predictable. So instead we want this to be random, but we want this to happen only a percentage of the time. So this is where we're going to use the probability idea. So let's say we put an if statement in here and we generate a random number, let's say between 0 and 100. Let's use 100 because I think it's easier to wrap your head around. So we'll say if this random number between 0 and 100, right, let's say it's less than 1, okay, then there's a 1% chance of that happening, right? So we have a random number between 0 and 100, right? And if it's less than 1, then there's a 1% chance, right? Another way to write the same thing would be to say a random number between 0 and 1, and if that's less than 0.01. Okay, that would be the same thing. We're just shifting the decimal places. Okay? I like to think of it that way personally better, but some of you might prefer to think of it in terms of like percentages, in terms of fractions of 100. So that's the same thing, right? Just shifting the decimal place. So this is a 100% chance of something happening. So we could say once in a while, right? Change your direction, right? And we don't want this to happen. Sorry, a 1% chance. We don't want this to happen too often because then they're going to be like really crazy. But now every time the zombie moves, there is a 1% chance, so see that's happening there sometimes, that it will randomly change direction, right? And just maybe it will slow down, maybe it will just start moving somewhere else. So that instantly makes our game a lot more interesting. Just adding a little bit of randomness and unpredictability to it will just make it a lot more fun to play. Obviously, the bigger this number, right? If we made a 50% chance, right? This means that the zombie is every other frame will change their mind and just kind of go a little nuts. So this is too much, right? So we can tweak this until it feels right. I find 1% is kind of a good probability ratio, right, for this particular game. But for your game, you might have different probabilities of things happening. So this is a useful concept, right, where you might, depending on what you're building, it obviously would be different. Maybe it's not the character changing direction. Maybe it's like something goes faster or whatever it is, right? You can make these random events happening using the random function and then an if statement, right? And you can define probability like this, right? So it's kind of like you're throwing a dice every time the zombie moves, and a 100-sided dice, and if that result is 1 or less, then something happens. Otherwise, this doesn't happen. So kind of an easy way to make things a little bit more spicy, a little bit more interesting. All right, cool. So that's going to be it for our game tutorial. Just to kind of recap, we're not going to walk through the whole tutorial again, but the reason for doing this, right, there's a few reasons. One is without realizing it, perhaps we've kind of recapped every single concept we've covered since the beginning of term. So everything is included in this one program. So this is always nice. But also along the way, we've learned a number of techniques that will translate to most game ideas, most game projects you will have. Not everything will be solved, obviously, but there's some fundamental concepts you'll be able to use for a lot of the games you might want to build for your final projects. The idea of having states in the program is really critical, right? If you want to be able to have a progression between different screens, you're going to need this concept of game states. The idea of collisions is very useful, whether it's between game objects or between the mouse. The mouse and a game object is even simpler because the mouse doesn't really have a radius. So you can think of it as the same problem, but with a radius of 1 for the mouse if you want to be very accurate. So it's even easier. And then kind of the general idea of thinking about what are the different objects that are making up this game, and then representing those using a little bit of a structure in the code. So here we created a player class and a zombie class. And what that allowed us to do is really start to organize our code a little bit more. And now our actual game logic becomes much more readable, much more manageable, right? This is what happens when we run the game. We draw and increase the score, easy to understand. We add zombies once in a while, easy to understand. We move, animate, and draw the player, and then we go through all the zombies we have. We move, animate, and draw them, and then do collision with the player. Okay, so now our game, our entire game logic, our game outline, it all basically fits in a few lines of code, and we've kind of like tucked away all the details into these commands, into these various functions. So this is, again, a great way to start scaffolding your project, right? Start small at the beginning, start with the absolute first thing you must have implemented, and then build on that, right? It's an iterative process. And you will, if you're strategic about where you start, then building your game should kind of happen naturally. And kind of going back to the beginning, this is where having a bit of an outline is very helpful as well. So spending a little bit of time up front before you sit down and write any code to kind of roughly plan out where you think this will go. It may not exactly go your way, but a little bit of planning up front will save you a ton of time in the long run, because it can be difficult to stare at a blank page and know, like, where do I begin this program? Well, start at the beginning, right? Kind of think of how we implemented this game. We started with, we need to draw something, so let's figure out the animation first, right? Then we need game objects, so let's program those. Then we need to add the logic to it. What's the core mechanic of our game? Let's program that. Then once we have this, okay, well, we can make a game. We can have a progression, right? And then let's leave the details for the very end. Oh, I also forgot. We have some music for this game. Let's add it. I was almost forgetting about this. We have this MP3 file here that we've included. That is, in fact, the last thing we're going to do in this video. We're going to add a little bit of background music just for fun, okay? So let's create a variable here. We're going to call it music. In preload, we're going to load music as a sound, right? And this here is my tune.mp3. This is a Creative Commons chip tune. I'll provide links to it in the description and comments afterwards. So we're going to load our sound in preload, just like we load all of our other assets. And just for dramatic effect here, we're going to play the song when we click to start the game. Okay, so when I run my intro over here, loading's a bit longer now because we're loading this file. It's bigger than all of our other files combined. When I select the player, I want to start the song. Okay, so we're going to do that at the exact time where this event happens, which is inside mouse pressed. Okay, so when we've finally clicked the mouse, we're moving into run game, creating the player. We are also going to start the song at the same time. Okay, so I'm going to say song.loop. And I use loop because I want the song to play in a loop. Okay? And let me put my headphones on so I can know if it works. Okay, it's not playing. Oh, I called it music. Sorry. Called it music in this version. All right, now we got some nice background music. Also a good idea, think about adding music to your game and some sounds. Instantly improves the mood. When it's game over and we try again, right, we could also reset the track by saying music.stop and then saying music.loop again. Let's try that. If the zombie eats me, right, we can try again, and then the song will go back to the beginning. All right. Okay, small detail, very important, almost forgot. So now our game example is complete. On that note, there was quite a few videos, so we'll leave it at that. For the rest of the semester, the following videos will be basically odds and ends in the coming weeks. Those will arise from your projects, so we'll cover things like libraries and just kind of very specific topics that might help you with some of your games. But for now, that's quite a lot to chew on. So I will see you in a week or two in some odds and ends videos. All right, take care.